Hello students, in this third video in the three block friction problem series, uh, we are going to solve the case 2 where the the force on the middle block is now going to be 12.5 Newton. And if you just recollect the problem where we have three blocks kept on the top of each other. The smallest is on the topmost box with 1 kg, which is block A. Then block B is 2 kg, and block C, which is the bottommost block resting on a surface, is with 3 kg mass. And the static and kinetic coefficients are already given, and a force F is getting applied to the middle block, and we need to find out the accelerations of all the three blocks. Now we have already solved in the previous video the case 1 where the force F is 5 Newton, and I will be giving the description in the description the links to the two earlier videos where the entire question was described, and then second where F was equal to 5 Newton. Now in this video we are going to look at the case 2 where F is now 12.5 Newton, and we will be solving this step by step. So to start with, because F is now 12.5 Newton, and we know that the middle block, the maximum frictional force between block B and block C, which we calculated in earlier video, is 12 Newton. So this force F is because this force F is more than 12 Newton, which is the maximum frictional resistance force between blocks B and C. The block B will now be set into motion under this 12.5 Newton force. So as soon as we start applying 12.5 Newton, the block B will start moving. Now, uh, along with the block B, the block A, which is right now on the top of that block, at that moment, it will also start moving, right? What will happen after some time, we will go into those details little later on. But at this moment, when 12.5 gets applied, block B as well as block A on the top of block B, both will start moving. And hence, let us call the acceleration created in these two blocks as acceleration of B and C. So when we look at the acceleration of B and C, let us now draw the free body diagram for this particular block B along with block A on the top of it. So we will consider them together, and now this will be the free body diagram. So if you can see here, the block shows A and B blocks put together. So it's a one block system together with a mass of 3 kg, and it is having a 30 Newton downward force and 30 Newton upward force which cancel each other, and we have 12.5 newtons applied to this system, and the maximum limiting force now it was 12 Newton. But the because the block is now in motion, we will have to consider mu k into n. That is the kinetic friction because the block is already in motion. So mu k into n is 30 Newton, the normal force where the friction is getting created, that normal force. So 30 into zero point 0.3 will be 9 Newton. So because the block is in motion, now the block will be experiencing a frictional resistance force of 9 Newton. So the free body diagram, we can put the equations that the mass into acceleration created by this net force will be given by the equation net force equal to mass into acceleration. So net force is 12.5 Newton and minus 9 Newton. So that will be equal to 3 because mass is 3 because we are considering the entire system together, that is B and A, not the block C, B and A. So 3 into acceleration of block B and C. Now when we solve this, we will get acceleration of block B and C equal to 3.5 divided by 3 or equal to 1.1667 meter per second square. Now we need to check, because of this acceleration there will be a force which will start acting on the block A, which is on the top of block B. So we need to check whether the force which will start acting on block A will create relative motion between the block A and B. Whether that force will create a relative motion between block A and B. So for that we need to draw the free body diagram of block A. So if you look at this, mass into acceleration is now the force which is acting on this block because of its acceleration. So it is, if you calculate it, it is 1 kg mass into acceleration. So it will be 1.1667 Newton. So this is the force which is acting on the horizon in the horizontal direction of the block. And you can see that we can calculate the limiting force or the maximum frictional force between block A and block B to be 10 Newton is the normal force, and static coefficient of friction is zero point 0.5. zero point 0.5 into 10 is 5 Newton. So because the frictional force, maximum frictional force, is still on a higher side than the force which is getting applied. So 1.1667 is a smaller value compared to 5. Block A will move with block B only, and there will not be any relative motion between the two blocks. Now we have to, so basically acceleration of block A and acceleration of block B will be same, will be equal to 1.1667. Now we need to look at the free body diagram of block C. So if you look at the block C now block C, it will experience a force, a frictional force, which was between the lower side of block B. Because the block B is now moving on block C, the block B will experience a 9-ton force on the left side, as well as equal and opposite force will be experienced by block C in this way. So 9-ton will be applied here, and this will try to move the block. Now we have a normal force of 60 Newton, and the maximum frictional force is calculated by the mu static into n, which is coming to 18 Newton. So 9 Newton will not be able to overcome this frictional force of 18 Newton, and hence this block cannot move. So 9 Newton is less than 18 Newton. Block C will not move. So the final answer is with 12.5 Newton applied on the middle block, acceleration of block A as well as acceleration of block B will be 1.1667, whereas acceleration of block C will be 0, it will not move. Now let us look at the case 3 in the next video. You can try out this yourself. Now F, consider F to be 25 newtons, and how the scenario will change with that we will see in my next video. If you are liking this series and if you want to learn more, you can always subscribe to this channel as well as hit the bell icon. Thank you.